Hi, everyone. Welcome back to another episode of Unscripted Coding. A few weeks ago, I did a video in which we really quickly, get this on screen here, really quickly wired up some computer fans to a wall socket. It was super simple. You just had to find the right power to it. But really what I wanted to do was put those fans up on a wall and basically have a window fan. Now, that's not really all that useful if I don't have something like a remote. And so I want to play around with remote controls for Arduinos. I have here two different remotes, two different receivers as well. And on your screen, you kind of see the two that I've chosen. The first one is an RF transmitter receiver. It looks very much like this one over here. We have a remote control to go with it as well. Okay, so there's that one. And then we have an IR remote as well. This one looks more like that. So let me just open these packages here. We have the IR remote over here. I think we're going to do this one second. No, sorry, this is the RF remote. I think we're going to do the RF one second because it should be a little tougher. And then we can do, let's just open this one, the IR one next. Right. Okay, so it's pretty cool. The IR remote should be just a couple of dollars. The RF one is probably a little bit more at $5 or $6. All depends, of course. But with the IR remote, I get this one, nice and cool, easy buttons. This one, obviously very mass produced. And then you get jumper cables. You get one LED, and you get this receiver as well. And you know, I realize I'm a tiny picture in the corner, so this doesn't help, but it looks very much like this giant one in the picture. So we have an IR remote and an RF remote. Now, IR, infrared, is really dependent on light. So this is why you get an LED. I presume this one is an IR LED and it can flash IR. You have a receiver that detects a light. Now IR is infrared, so think of it as a standard LED. It's outputting light, but the whole thing is IR is a spectrum your eyes can't really see. And so what that means is this receiver is able to see the light, but you need this LED and this receiver to actually see each other. If I put a hand in between, let's say I put it in between like these two, put an item in between them, it's not going to see the light coming from this LED, and so it can't pick up anything. In short, what that means is you need a direct line of sight for it to work. Now, RF, on the other hand, is radio frequency. So, you know, if you turn on radio on your car, you don't need to be in the line of sight of a radio tower. It kind of just moves along. And so one of these remotes doesn't need to have a direct line of sight. And so I could be pointing left, right, it really doesn't matter. It's more expensive. I think RF takes more energy, and I have to say, there seems to be fewer projects that use RF. So even this remote, there's only 4 buttons. I'd like more buttons, but there aren't that many options for you to choose from. Whereas with one of these IR remotes, there are so many, because every other project uses some sort of IR remote. And finally, I have another Arduino. So I just have so many of these. I ordered way too many way back when I was super excited about electronics. So, I'm gonna toss this aside. I might keep this bag. Okay, so this is an Arduino Pro Micro. None of these are particularly demanding things. So if you have an Arduino Uno, anything else, Nano, Micro, whatever you have, this project should basically go the same way. I'm going to stop talking for a moment. I realize that these ones need to be soldered on first. So you can watch me kind of do a bit of soldering on the side. And get ready to put this onto a simple breadboard. Again, I realize you guys can't see very well. So be back in a moment. So what I've done is just put in the little legs called the headers. You see how they're sticking out? Quick tip, if you ever do this, don't just stick them on and start soldering. I would just put the pins right onto a breadboard, put the thing on top so you know that it lines up and it's nice and straight. Okay, so let us look at the tutorial. I have a very similar chip with the 3 legs as well. They're labeled plus, minus, and I'm not sure what the last one is, but it looks very much like this one right here. Okay, so plus is in the center, minus is the ground, and then you get the signal at the very top. How have they wired it? The S is the signal, and they have put it to pin 7. I think that doesn't really matter. And then we have, of course, ground and 5 volt. So I'm going to use these wires that they provided in the kit. Let's just put them right in. Not sure this is the greatest idea. I might use a breadboard, but we have so very little to do here that I might as well keep it like so. So pin 7. Oh, I can't just pick a random wire, of course. Pin 7 was the signal, so purple's this one. Pin 7. Okay, so positive, they gave me blue for positive. That should go towards the 5 volt. That will go to, I think, VCC. And then finally, the green goes to ground. Okay, so very cheap wiring, very simple wiring job. I'm just gonna plug this into my computer. Okay. Now, they have already provided some code. And they have suggested that we include the IR remote library. Let's look at libraries. And get the update. IR remote. Let's see if it's being installed. Nope. So excellent. Installed. And we will just copy over the code. All right, open this bag as well. Grab this. Oh, hope they gave me a battery. Okay, so of course they didn't give me a battery. Let's just take a look at their code first, and then I gotta find myself a CR2025 battery. They have asked us to connect it to pin 7. They're declaring it as the receiver pin for IR receiver, and then they have created a variable called decode results. Let's just add a bit of spacing here, and that should be close bracket. I think there should be one more close bracket. Let's just pretty up the code a little bit so that it's readable. Okay, let's not waste too much time. They're starting the serial, and then they enable IR. That's the first thing that runs. And then what loops for the Arduino is it's going to check, see if it gets any results. 0 if no data is ready, 1 if data is ready. So if they are getting some sort of code, results of decoding are stored in result.values. So you get the results, and then they are making a bunch of print. They're going to get the code, they're going to get results value, and then restart the state machine. Interesting. I'm not entirely sure what that means, but I figure that means clear off the remote code, start detecting again. So I'm going to go find myself a battery, and we will continue. Okay, it took a bit to find the battery, but we have our wiring here. I am just going to put it here, and I am going to upload it. Oh, something's wrong here. Is deprecated. Well, doesn't matter. It has uploaded anyways, but let's just remove this as suggested right here and see if we can go without errors. Okay, that is helpful. Now we're going to pull up the serial monitor, and we're going to point this and see. So I don't know if you can see that, but the receiver blinks as soon as it receives a code. what is interesting is that we're not getting the right value. So it is returning 0 all the time. Value equals results. Oh, okay. So I had to include this results unless I find the library, see what the proper instructions are now. Let's keep it and results. It is deprecated, but let's not reinvent the wheel here. Oh, I didn't show you guys. I was on the wrong screen. It was just showing 0, 0, 0 every time I click anything. So that doesn't help if it doesn't detect which code. So we have a new code. And I find it very interesting that this cheap remote, the number 7, doesn't seem to work. Okay, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. I am going to record this on a notepad on the side so that I know what code it is. Let's go with 1 again. 1. And 2. 3. 4. And I'm not really going to waste your time just going through each one. So what I want to do is change it so that I can detect what the value is. If value equals, and I think it's an integer. It's 1. Print. Print. 1. Okay, we'll upload this again. And let's hope that it can figure it out. So we're going to press 2 first. We know this isn't going to work. Now 1. And perfect. It does detect it. And so what we can do here is we can start doing other things on the Arduino. So perhaps we have an LED connected to pin, I don't know, 6 or 5 or wherever. And we can turn these things on and off just by detecting what number is being called. So this is a IR remote, infrared, and it requires this detector right here to actually see something. And so as I demonstrated before, there's the receiver right here. You see the blink as well when I click a button. However, if I point this upwards, oh, actually, that's very good. It's still detecting, but completely inaccurately when I point in various places. But I'm actually quite surprised that you can turn left and right and still get some sort of response. I don't know why that is. But yeah, if I'm doing it behind my back, the code is completely incorrect. But if we start clicking, oh, and sometimes it doesn't even work. But if it's clicked and if we're detecting which code it is, that will help. Okay, so that is the IR remote. The next one that is interesting is the RF. So I'm going to tinker around with this for a few minutes before talking again. Okay, and so again, all of these remotes, none of them seem to come with batteries, and this one in particular seems quite common on eBay and AliExpress and wherever you want to get them. It uses a battery that I've never seen before. The height is like maybe 2.53 centimeters. I don't know what battery that is, but I just jammed 5 or 6 LR41 batteries just in a row. Probably not ideal, but you want to get to the code. Really simple. We got this RM4. We got this RM4 library. And I will link to it in the description so you guys can get a chance to play with it. Let me just note this down on my notepad. There will be a bit of manual library install. You gotta just drag this into the library folder in your Arduino install folder. But what we did then is we just connected all of the pins, and at first I didn't realize that this is where they create the remote. All of the pins are being used, and so you probably can just stick it right down. The 5-volt can turn on and off the receiver so you don't use as much batteries. You don't use as much power, and then the rest of the D0, 1, 2, 3 gives you the signal. Now, what is really interesting here is the actual results. I'm jumping ahead of myself. Let's look at the code again. You turn on serial, and then you basically digital write, so put power through the 5-volt pin. So you get some power coming through this receiver, basically turning it on. In theory, that means you can turn it on and off over time. So you may use a timer, you may use a Bluetooth module, something to turn this on and off at a later time. And then you're just constantly looking for a button code. you keep searching, and it uses this remote feature to find out if a button is pressed. And so the 4 buttons I got had code 8, 2, 1, and 4, which corresponds with A, B, C, and D. Now, once we have the serial monitor, we can just start pointing and pressing and getting the results. Now, again, you're looking at this going, what does it matter if we can print this in serial? What help is it? Simply put, you are using this in conjunction with something else. You're going to attach other things to this Arduino, whether it's a motor, it's an LED, it's a sensor, or whatever, and you can start controlling things from far off. And our future project is we're going to be taking these computer fans, sorry, they're tied to a wall there, but we're going to be turning these computer fans and using one of these remotes to actually do something. Now, I thought I was going a bit crazy, and you may have seen me actually search up what the difference is between IR and RF remote. I was horrified that I may have been feeding you incorrect information all this time. IR remote, I made a big deal about pointing towards a receiver and the whole line of sight. And it's absolutely true. The IR remote needs a line of sight, but we were able to get some shifting around. And I think it's just because the LED here is quite strong. So maybe it's flashing against the wall. It's showing up elsewhere that this is picking up. It's shocking to me because this is an RF remote in theory, and like even a little ways off, I'm just getting nothing. No response whatsoever. I got a point pretty close and right at the board to get some response. And to me, it is very interesting that this has been such a horrible remote. You can see RF. It's supposed to be long distance. It's supposed to go through objects. You don't need the line of sight. And yet this controller has done very, very poorly in comparison to this, which is a standard IR remote. Now, again, if you're like doing this behind the chair, you're going to get very poor reception. But I think what it is this is a really bright LED. You can't see it with your eyes, but IR is shining off against a wall or somehow letting this sensor pick it up. So if you're trying to do this from another room, you're probably going to want to look at an RF sensor. Now, not this one. This one has been absolutely horrible. So what that means is I'm going to unplug these. This one has not been useful at all for my purposes, and this will go into my collection as an interesting one. My theory is that these ones have been so very mass-produced that even though they feel really cheap and it's like really cheap plastic, that they've really nailed the sensors, they've really nailed the remotes. Whereas if you Google an RF remote for Arduino, you're not going to find a lot of these boards. This one, I had a hard time finding the right code for it. It's not listed. This is not very common. You can feel that this has not been well designed. So mass-produced, even though in theory the tech behind this should be limiting, I'm going to be going with an IR remote for my future projects. And they're also cheaper. I think this was $3 in total. It's like half the price of an IR remote. So very interesting test, I think, in terms of how well these perform. But we have the code for both of them. And yeah, overall, I think they're both very self-explanatory. You start your serial, you use the library, and you basically start detecting whether you receive something. And so I will be doing a follow-up video where we're going to bring together multiple projects. So the computer fan, again, I'm just getting an edge of my picture here. I connected to a wall. What I want to do ultimately is be able to control it with one of these remotes. And so you start building these really short, simple projects, and then you start putting them together. That's kind of the exciting part of this. I'm going to uncomment this so that I know that this is the one we're going. Anyways, that concludes this video. I hope you found it helpful. If you're ever getting remote, you now know you want to get an IR one for Arduino projects, unless you have a very, very special use case that you have to do something behind the wall. I would still recommend maybe finding a better receiver or a better remote or some sort of combination that's different from mine. Now, if you enjoyed this video, please give me a like, please subscribe, please give me a thumbs up. But if you didn't, I'd love to hear about why, so feel free to leave a comment. I'm just mucking around trying to build these as I go, so I know that this isn't a true tutorial, but we get to have fun, we get to build this on the go, and you get to see the whole process. So thanks for watching, stay tuned for another video coming up real soon.